Okay, welcome back. I hope that without any technical issues. And just to remind us, all of us, what was the topic of discussion? The topic of discussion was to talk about true engineering. Yeah.
Mm-hmm.
And we have two great experts. We have Tom and we have Jarek. Tom, you are working in this domain for a long, long time, many years. You wrote several books. Yeah. You are the expert in engineering and software engineering in the requirements field and so on. Jarek, you are also working in the field for at least several years, 20 or something, right? Or
Yes.
30 even.
I start 1991.
Okay. So ancient times. Yeah, a long, long
I'm really
time
old guy.
ago. Okay. I don't have some big experience. I am mostly in business analysis. I'm also trying to do requirements engineering, the proper requirements engineering. And this is for me the main goal of the discussion, to understand what is engineering according to you. Yeah. And let us
Mm-hmm.
start from the very beginning, from the core concept. What do you guys mean engineering? We are talking about, well, software engineering, requirements engineering. And I know that many people are treating engineering as just coding. Engineering is coding.
No,
No. Okay.
no.
So maybe Jarek, you will start, then we
Okay,
will
I
ask
try to.
Tom.
I found special, especially for us, really nice definition. One moment, please. I have to do some copy paste. Um, uh, 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 okay, yeah, okay. One moment. Uh, this is a part of the quite Oskaya building block. Yes. This is a. Oh, where's my video? One moment. Oh yes. This is a. It's a really nice thing because the programming is not solely about construction software. Programming is about designing software. Yeah. There's a really nice sentence. I was catch them is that paper is for free. And
Mhm.
my view is it's a similar my background, yes, because I'm a technical man, technical guy, but but I'm not a strictly programmer. Um, my background is general engineering. Yes, it's for me. I see that we can preparing the car. I don't know, dishwasher. We can preparing a software, and just now we see that, for example, I got new laundry 3 years, 3 days ago, and we have big machines. A lot of part is mechanical, but the one part, this is the programming. You can choose the program like wool, jeans, and so on. This is a probably 20 years ago, it was small machine similar to watch, yes, a lot of small wheels inside. Just now, this is a small computer.
Mhm.
But that's computers, it's small part of that laundry machine. It's two exactly the same. It means when somebody designing the laundry machine, we have a part and we have a requirements. Yes, I need the signal to start the machine washing, stop machine, got the water, the pull water out, and so on. And what the difference between my watch? I have mechanical watch and watch in my Windows. We use this for exactly the same. Yes, I need something for control the time. When somebody asks me what the time is at, I see this is my screen. Yes, I say it doesn't matter if it's a computer or no. It means if we talk about the requirements, we have a first level. It's something we use for what? Yes, I need something for. This is my business requirements. And the second one is the Second stage, if you say, okay, I chose a programmer to preparing, to design, to implement my watch. It means the same things. If I say, okay, the programmer will be preparing implementation, is the requirements for programmers. When I go to the mechanical factory, I say, okay, this is my requirements, but that guy used a hammer. They're not coding. And I say, if we talk about requirement, we have to divide the discuss about business requiring. We have a black box. We use this for. And last time we talked, this is a requirement for functional, non-functional, constraint, and so on, so on. But if I say, okay, maybe I go to the programmer because I need this a computer implementation for my watch. It's a totally different idea, but the black box working the same, but the requirements totally different. And we say the model or the design as a requirement. Sometimes I am a person who said, okay, if we go to the any developer, we decide about the implementation. Who do this? The blacksmith or coder? It's not the same, but this is still the same black box we use this for. It's my view of requirement because I have to know who is the person, who is my customer. Yes, is my customer sometimes a coder. I have to prepare something architecture, yes, for software.
So what I think you are trying to focus on is that we can talk about different levels of requirements, business and at least system, solution, whatever, however we call them. Okay, and that's the subject of requirements engineering, and coming back to my idea, what we are talking, what we mean when we are talking about engineering at all. Tom, I know you wrote something like 2, 3, 5 books on that. What's engineering?
I try another picture. One moment, please. Maybe no. Yes, probably it's working. It's not a picture. If you try this URL, you see that's a part of the vocabulary. Yeah, did you see this? We have a science and we have engineering.
I can just see it. Yes. Science is the branch of and so on.
Yes. This is a definition. I agree with this.
So engineering is a professional art of applying science to the optimum conversion of the resources of nature to benefit man. Okay. Yes. So that's the definition. Tom, how do you feel about that?
Okay. Well, I distinguish in one of my earlier books between what I call a soft crafter and a software engineer.
Okay.
And the soft crafter simply follows convention, tradition. They just start doing their work. They're told what to do and they do it. They write in English, but they program the way they always program, maybe following some conventions, but conventions. Now, engineers come in where the convention would not give us the quality or performance or economics that we want. So we bring in the engineer and say, engineer, we want twice the reliability at half the price. So we're giving some requirements. And I'm simplifying, of course, a great deal. And the engineer says, how am I going to get half the price? How am I going to get twice the quality? And they say, okay, design for quality is X. And this is a new convention that the conventional programmer does not normally do. It could be different programming language, for example, or automatic generation of programs via artificial intelligence, okay? And they do the same thing for the cost. How are we going to reduce the cost? And the programmer says, we need to outsource to a cheaper cost country. So the work will be done by soft crafters, but in another country. So in other words, the engineer is trying to achieve certain, let's call them qualities and costs, which will not automatically come from the normal craft.
Mhm.
And so they have to think how we're going to do it, find a way, specify it, and people have to do it. Okay, so that's the essential distinction, and the requirements drive this. These requirements, twice the reliability, half the cost, they are inputs to the engineer who has to figure out a way to do it in practice.
Yes, so probably we talk about maybe similar or something the same, but just now I put two definitions from the one of recruiting company from US, and they define this that it's a software engineer is a software engineer that evaluate client of company needs in conjunction with the user methodically conceptualize and systematic solution. Yes, it's generally designing, but the programmers write code and debug and so on and so on. It's I agree that part is the craftsmanship. This is a craftsmanship, not designing. That's if we talk about the example about my watch, one person designing this, but second one make an implementation. The second person is a craftsman. It's not engineer, because so many times when I try to find this definition about this, I found that the engineer is the art, is a designing and the word like this. But a lot of times we use the word as a craftsmanship. Maybe you bought, yes, that so many times we can find in software engineering books the topics like software craftsmanship. I remember one of the books have exactly titled Software Craftsmanship. It means the coding is activities who make the things, not designing this, make this. And I remember it was about 50 years ago when I was in the Babok course. The trainer taught me one nice important thing, that in Babok we can preparing requirement as a black box or a white box. And I don't know what about this a new one. That's 15 years ago in Babok, I found this a really nice idea. We can describe in the black box and we can describe it a white box. White box means internal architecture. And they say this is another stage of the requirements. I say it's a good idea.
Jarek, because in theory, if we are talking about requirements, we are talking about the what we need level. We are not talking about how to do it, about architecture, yeah?
Yes, but I remember this requirements. I remember this black box and white box, both of them, Babok call this requirements, because we can send to the factory description of the black box, or we can send to the factory, for example, for craftsmen, yes, our coders, we can say documentation about the white box. Why not? It means about that's what I can say. Okay, I need a device. Every minute have a 60 seconds and so on, and I can say, okay, can you prepare something with 4 wheels? This is a scheme of this. It's probably, yes, this is a risk. When somebody, I remember that the trainer taught us, if you can't see any risky project, you can send your requirements as a black box. If you feel your project going to be risky, prepare the white box for coders. That's something similar, something like this.
And the question is, are these things still requirements? Because for me, they are not requirements. That would be designs, architecture. Yeah, Tom, what would you say? Because I know that you are an expert in this field.
Okay. Well, okay. So let's try some simple definitions. Requirements are a future state of the system that we require. And in simple terms, we can think of all the qualities and performance states, secure, safe, user-friendly, speedy, things like that. Okay, now this quality requirement does not tell you how we are going to design it or how we are going to code it. It just says, whatever you do, it must be so and so user-friendly, so and so secure, okay? So it describes an abstract idea. And the job of the engineer is to pick some practical way to get there, which we call the design, by whatever name, okay?
Yes, but that's words probably have more than one meaning because, for example, in I don't want to found us now, but the word requirements means is the feature we need. This is a feature we need, yes. And the second question is what we call the feature, because I can say the feature is I want to see the time is now. This is the feature, yes. This is showing that's what the time is in. But when I say my car have 4 wheels, this is a feature. I can say, okay, I have I remember when I was in Italy, I seen that's a small car, 3 wheels, and I seen car, typical, having 4 wheels. And my question is, can I say I need a car with 4 wheels? This is my requirement. This is my requirement. I don't want a car with 3 wheels. I need 4 wheels, 4 because I need a nice SUV.
For me, the issue is the in theory, a requirement is a capability I need to solve my problem. I need to achieve for some reason, yeah? And if I am able to prove that I need these 4 wheels because this is the justification, maybe this is a requirement. Because is it really my need to have 4 wheels?
It's if you want something to driving, you can buy a bike,
why not?
motorbike.
If I need to move from point 1 to point 2, I can do it by car, by train.
I think that's the thin border is because we have 2 ways. When I think about maybe particular car, I can describe that car as a black box, and the salesman in the car dealer choose the best for him, not for me. Because if you say, okay, I need something to driving because I want to move from here to I don't know somewhere, the salesman try to sell you cheaper the things who the best business for him, yes, because maybe you bring a bike, yes, because you forgot, okay, maybe not too fast. Not too fast, you can driving by your legs. Okay, why not? It's a quite risky idea, yes, but so many times people say, okay, I have a better idea. I say, okay, I need something to driving from here to somewhere, but I want the 4 wheels. Why? Because it's a stable machine and so on, so on. Why not? And the question is, can I say I need a 4 wheel or no?
Tom, can you comment on that? Because again,
yes, of course,
for me,
of course.
that's not really a requirement. I want 4 wheels. That's not the state, right?
It's more complex than that.
Okay.
So the future, now we still stick to the idea that a requirement is a future state, desired, not mandated yet, maybe they can't afford it, desired by a stakeholder. Stakeholders defined as those who have requirements, in fact. Okay, now, there are many different types of requirements, and I mentioned one, which I call performance requirement. That's a systems engineering term. And performance requirements include things like how fast, how much, but also all the qualities, the usability, safety, reliability. Now, the performance requirements are all abstract. That is, you can say how good they are, but this doesn't say how you make them so good, which is the design. Now, there is a special class of requirement called a constraint. And one of the types of constraint is called a design constraint. Now, let's just say we decide that we want 3 wheels because we want 3 wheels, because we love 3 wheels. And we say, I have a requirement that you do 3 wheels. And that is not a performance requirement, although it may affect performance. It is a design constraint, and that is a valid class of requirement.
Yeah.
Exactly. To name it requirement, shouldn't we provide a kind of justification? Why do we really need these 3 wheels? Not 5, not 4, but 3.
I understand that some say the constraints is the part of requirements. For example, Tom, if you want to buy a new boat, can you say I need boat? I want the boat made of wood.
Yes, you can.
It's your constraints. It means you have another requirement. I need a boat made of wood.
Yeah. So, Carolina, your question was exactly.
Shouldn't we provide a justification to understand the value of the requirement?
Yes, I am a fanatic believer that any requirement should have a justification, and it should be in writing together with the requirement, so people can understand and sometimes say your justification is not valid for this requirement. They can discuss the requirement more intelligently. Yes, but now that is not a normal practice. Some do and some don't. Some, even in a user story, there is a sort of justification built in. Very, very good. But it is possible to give requirements without justification. It is a much better practice to demand that the justification be included from the people who write the requirement. It's a healthy practice.
Yes. Just now I see that probably we have to divide the 2 fields of we're talking about, because I agree. I startingly agree with you, Tom, but I say that we have to talk about the 2 different engineering requirements. And sometimes I found a science paper, abstract machine, abstract mechanism. Yes, it means that we have requirements, especially the source of this is our stakeholders. But probably sometimes, maybe not all the time, sometimes we need a person who prepare, invent, design the mechanism. Yes, because if I say, okay, I need the 3 wheels car, I don't want to provide no more details, but the key parts, I need the roof and 3 wheels and the engine on my backside. This is a 3-mile constraint, yes? And the question is, this is a requirement or abstract model, maybe?
Okay, so I made a little note to myself. I think we can usefully distinguish between defining a requirements engineer and a design engineer.
Yes.
And they are not the same. They could be the same person doing 2 different jobs, but they are 2 different disciplines. So let me try a quick and simple definition. A requirements engineer has learned the discipline of specifying requirements very precisely for things like all qualities and all constraints. They've learned disciplines like, Carolina, we should include the justification and the source of the requirement and things like that. So they have learned, they don't just throw out a few words, I want better usability. They have a whole page, like in my planning language in the free competitive engineering book we're going to give everybody, a whole page of 20 different parameters One of those parameters is, how is it justified? Another parameter is, which stakeholders are behind this, okay? That's requirements engineering. It is very detailed and technical and appropriate to larger and complex systems, not for a simple one-day programming task. Now, the design engineer takes the input from the requirements engineer, the engineered requirements, and has a rich picture of how good should it be and when should it be delivered and why is it justified and which stakeholders are behind each requirement, and uses this information to find one or more designs which will hopefully give the right level of security at the right date, concurrently with, for example, the budget for the entire system. You cannot just come out with a design which is twice as big as the whole budget for the whole system. So the designer must consider a large number of concurrent factors, each one of which, like requirement, maybe one whole page of 20 different parameters, and somehow envisage solutions and evaluate and analyze them. For example, a real design engineer would say, not only will this design get me to my safety level, but they will ask questions that engineers call side effects. They will say, are there any bad side effects on performance and cost? You see, side effects analysis. That's a design engineering task. It's not a requirements engineering task. It's a design engineering task.
Yes, probably I see that's I clarify something. If I understand what I want to say, this I see that's the common situation. Some people talk we need requirements because somebody preparing implementation. So many times people means thinking about the two stages: requirements engineering and implementation, coding. But so many times we need put inside the designing stage, we can call the system design. Not too much details between, for example, okay, I have a laundry machine. I need the small things, the small box for the something for the choose the programs. I can't decide this is mechanical, maybe computer, but the system design, if we talk about the laundry machine, car, and so on, the system design is a quite abstract idea, but this is a white box. Yes, we can say, okay, I have a 3 wheels car. My steering wheel is this one. I have a roof. I have an engine in my backside. There's some key design decision, but the car factory preparing all the 1 million details. Probably the problem is, I see just now, that we have to talk about the 3 stages: requirements analysis, and in the end, any type of implementation, but a lot of time, maybe not all the time, system design as a second stage between requirements engineering and implementation. We have a stakeholder and we have a factory. Stakeholder and requirement engineer preparing requirements, the factory waiting for this, but probably inside, maybe not all the times, we need a system designer, some big parts, how it works. Sometimes in science, we say that the mechanism, yes, it means I don't know a details about I don't know our planet and so on. I know that we have a few balls, the sun is the inside, 9 planets, do something like this, that's all. This is my view. This is a system design, 5, 6, 15 blocks, not 2,000, or I don't know, 1 million code of line codes. Maybe we have to talk about the stage inside, system, high-level system design, something like this. Maybe this is, because I see that's probably I miss the border between the requirements and system design, maybe.
No, let
Okay.
me comment on that because both you guys, you said something very important for me. The thing that the border is not so clear, which means that and that's my practice, that yes, either they will expect from me, a business analyst, that I will provide requirement specification that is complete enough to allow the developer to code.
But
Or-
sometimes not enough. If you
Yeah,
if
because
you
well,
if
this
you
is
if
not
you
my
have a
area. My
requirement,
area is to
yes.
define the need. This is what we need.
yes,
The black box,
yes.
not how to do it. I'm not
Yes.
technical. I'm
Yes.
not architect.
Yes.
Yeah, so that's one
Yes.
problem. And the second problem from the other side, again, something that I am seeing very, very often, the requirements that we have. Tom, you mentioned something that they should be precise. We are talking about hello engineering. They should be precise. And I am seeing things like the systems should be user-friendly. The end.
2-3 weeks ago, I found really nice and really useful presentation in the YouTube. I forgot the title of this, but the main idea was requirements is the problem to solve. This is not something to coding. It's not the same. Requirements is a list of problems to solve, and the engineer, this is a person who's solving those problems. I can say, okay, I need invoices. That invoice have to correspond to my proposals. Okay, is my needs, is a requirements, but the coder probably asks what I have to coding.
Mhm.
I don't know. We need
Yeah.
inside the person who preparing this system design. We need a database, we need block 1, block 2, and so on, so on. It's workings like this. This is my big picture, maybe 15 pages. After that, coders start preparing this a million line of code. And I mean that's when the problem is not too big or it's not too risk, it's quite good. It could be good idea. Yes, your requirements, you can put this direct to coders. If you see, okay, it's not too risky idea, it's probably working. Sometimes we can say in that situation, this is agile. Yes, the coder preparing maybe one by one your requirements in the code. But when the problem is a little bigger, we need, sometimes we say, I found a solution designer. I don't know what this means, but it looks nice. It's here. It's probably there's a solution designer, system designer, whatever. It is this is the role inside. Yes. Maybe I remember the book from it's written by maybe Jacobson, I'm not sure. He wrote, okay, if you start preparing this small building, maybe something for your dog, you can start preparing this without any designing. It's safety. If you start preparing this medium house, 4 levels, try design before you start build. Maybe this is a good idea because we have a requirements. When we finish, we have a nice building, but we need something inside because it could be quite risky idea preparing a 4-stage, I don't know, 2, 5 floors building without any ideas. Yes, it's maybe not a good idea. Yeah.
Okay, so again,
So-
a couple of thoughts. Tom, can you summarize a little bit because we have quite a lot of information here. Yeah, the first information, is it really okay that my requirement is so general, like the system should be fast, whatever, or should I go to the different site and should I prepare everything that is needed to implement, or we really need something that for me is a kind of obvious. We need the middle side, we need the design. I provide the business need, they provide the design, they are coding.
Okay. As Jarek was hinting at, the smaller the system, the more informal you can be, with
Mhm.
regard to information to but the larger the system, the more engineering and architecture you require. Now this we can see everywhere we go.
Yeah.
Larger, more complex systems demand engineering. And now, but I wanted to bring up something related, the difference between architecture and engineering. See?
Mhm.
Now, at one level, they are the same thing. They are taking some requirements in and outputting some designs, both of them. But what is the difference? Well, in a larger system, architecture tries to be the designer for the whole, everything, the whole system. And that means code and databases and hardware and people and organization and motivation and contracts and everything. The architecture responsible for everything. Now, let's just say you need extreme reliability. There is such a thing as a reliability engineer. They do nothing but make engineer systems to be more reliable. Take usability engineering. We just often call it UX, user experience, but these are
Yes.
specialists who really do nothing except they engineer the usability, okay? So we can think of it this way. In a larger system, architect is necessary for tying all the specialist engineers together. And the specialist engineers are there to do extremely much better in their discipline than a mere architect would be, who is not a specialist in their discipline.
Yes.
I didn't directly answer your question now, but I wanted to get that point in here. This idea of architects managing sets of engineers in the larger systems, but not in a small system. Now,
It makes sense. If you have a small system,
Yeah.
2 requirements or 3 requirements,
Yeah.
that's, well, I could be a coder as well.
Yes.
Yeah.
Because
Yeah.
the complexity is the level of complexity of the risk is different, yeah.
Yes.
And when you are talking about banking system,
Oh yes. It's
some
not,
of these
yes.
banking systems are, I worked a lot in banking, and
I know.
the banking systems are very large, complex, and they are processing, one mistake is $1 billion a day. That
Yes.
kind of,
it's
this
not
is
we
not
have
trivial.
a back on production, someone will be angry. It's about money, a lot of money, yeah.
Yeah.
Okay. And
Well,
we
but
started talking
did
about
I answer your main question was about precision, I think. And
yeah, because
just
that is something
re-generalize.
though that I can see
But-
is really a big problem. The quality of requirements.
But here's the thing. The larger and more complex the system, the greater the precision in requirements is necessary. So once it is a trivial small system, one guy is going to hack it together in a few days of coding, you don't need much precision.
Mhm.
Okay? But as you scale up, more and more precision will be necessary. Give a simple example of precision that's one of my favorite. This is about the AT&T Bell Labs telephone system in the US. And they had found that they had availability, meaning you could make a call successfully, of 99.90%.
Mhm.
Pretty good. Remember, they don't get paid unless they connect the call. And somebody said, if we could get to 99.98, 0.08 more, we could earn a lot of money over time by more connected calls. So they said, let's do it. So here's precision, right? You're moving from 99.90 to 99.98 in one quality of many qualities. It took them 3,000 people for 8 years to accomplish it. So they did it. So there you see scale. I mean, this is the whole US telephone system. A lot of money flowing through it.
Yeah.
They are already at an incredibly high level, 99.90, 4 digits. But 1 digit is thousands of work years of effort to get there.
Yes.
So precision is necessary because it's a lot of money.
And I see that's clarifying to me that generally we have to divide the stages about the system design and the requirements design of engineering, because if we talk about the not information. We can talk about information technology, but if we talk about other engineering, you can say, okay, I need a boat because I want to moving through the river somewhere, and my constraints, and I can say my constraints, I need a wooden boat, but the factory ask me, they have a technology guy, why you want wooden? It's easy to fire. I suggest you, we build your boat from the metal. It's made of metal. Okay, why not? And the question is, who wants to decide about materials and why? Because we have a stage about the technology. We can choose more than one. We can prepare, we can make, that's boards could be made from the metal, paper, waterproof paper. I see this. Maybe we have so many technology for preparing a boat. And the question is, who decide about that material? Maybe Tom said, I don't know what you want to mean. I need a wooden boat. Why? Because
I want. Yeah.
Why not? It's my constraints. Can you explain me why? No. I'm stakeholder. Sorry. Wooden, please. No metal. No other one. Wooden, please. I love wood.
Good question, Jarek. Not so obvious answer. Well, Tom, you will comment on that because for sure you will.
Well,
you will
yeah,
have some
I've got
things
2
to do.
points lined up in my notes.
Okay.
Now, first there is this thing about imprecise goals. Now, in my requirement specification language,
Language.
free book, competitive
Yeah.
engineering, I have a thing called ambition level, and I have a thing called a scale of measure. Now, what I do, I find that the big boss, the big stakeholder, they have not learned the precision that we might need. And they just say, I want a hell of a lot more security. So I could go back to them and said, you know, you are stupid, uneducated, you're not precise like I am, but I think I would lose my job very quickly. Yeah. So I go and say, thank you so much, big boss. We will write down as the ambition level for the project, we want a hell of a lot more security, and we will put your name on it to make it official and give it power. And to make sure that you get what you want, we will, as the systems engineers we will define a scale of measure for security. I make a simple one, the probability of getting hacked and discovering within 5 seconds. Okay, that's more precise. And then we, not only that, we will even show you our scale of measure, and you can decide if you want to that you like it or you don't, or you don't even want to deal with it. Just you know, they might choose to stick at the. But so in other words, this is how I handle these imprecise things. I accept them as that's what you're going to get, because you're not going to train these guys to be engineers. Yes. Okay. They have the power. It's good enough to its direction. I want a hell of a lot more security. That means not 0.00001% more. We're talking like 30% more or some big number, right? So I have to put big numbers in there to satisfy the hell of a lot idea. And I have to define security, whether I use hackers or something else. It doesn't matter for the moment. Now, so that's how I handle this. I integrate it. I say, yes, I document it in my requirements engineering document. And I blame them. The boss said a hell of a lot security. I put their name on it. I make them aware that we are quoting them. Say, if you want to change this, this is the one that has your name on it. We as engineers in this very large, expensive system will make sure you get the security you want. But we're going to have to put some numbers on it. But you don't have to look at those numbers. That's technical stuff inside the black box. Now, second question. We are talking as though a designer just makes a decision. And sometimes that's exactly what happens. But you know, there's something emerging I have a book that we will give to everybody called Musk's Methods. And we're talking Elon Musk and Tesla and things like that.
Mhm.
Now, his method is to make a pretty good design, but as he says in one of his 5 core principles, assume that the requirements are wrong, no matter who stated them or how intelligent they are. And he's indirectly referring to himself. Even if Musk says what it is, don't take it so serious. Assume the requirements are wrong. And then work to make them better and better by getting feedback and learning and other people, teams, and make them better. Now, he says the same thing about design. Assume the design suggestion at the beginning is wrong, but work, and they are fanatic and innovational at Tesla. They have teams, mob teams, they call them, like 6 people, who work for 12 hours straight. And during the day, they try to make a slightly better design and actually try it out and maybe even install it on production cars, right? Then, and they, in fact, they introduce on the cars between 30 and 60 changes to the production of the car every week. Remember, normal car manufacturers every 5 years, new model.
Yeah.
So the rate of change is horrendous. But so there's this very dynamic idea. It's a very agile idea too, by the way. I think Musk is the master of agility, the best practitioner, because he is doing these increments every day for real. He's getting his teams to do it that way. And they do not settle for the original requirement or the original design. He says very clear, it's in writing in the Musk Methods book. Assume these are wrong, assume we can make them better. You have the budget, the money and the power to, as you're in your team, to make the changes and see if they work. And if they do, we keep on going. And if they don't, we go back and try again. So this is really the most modern way of doing things.
Okay,
Jarek,
but I have a question.
Just a second, Jarek. Let me comment on that because it's fantastic. And now that's perfect. I really like it. And now come back to reality. We are talking about software vendor and we are talking about customer. And we are talking, Jarek, I think you know what I'm talking. The customer says something, provides requirements. What does the software vendor does? Accept the requirements without asking, challenging, nothing. If something is not clear, it's the customer fault. We are blaming the customer. Yeah. And is it the engineering that we want? Because for me, it's just like, well, in my understanding, we as business analysts, engineers, whatever, we are a little bit about helping customer, providing advices, challenging, not just taking requirements and writing the code on the basis of requirements.
Probably I have a good question for this. I see, Tom, I imagine your boat is made of wood, but your fire made of stones. Who decide about this?
My boat is made of aluminium.
Okay, sorry. Could be, why not? but your fire was made of the stone. Who decide about this? Why not aluminium?
Well, I chose aluminium because I had experience with previous aluminium boat, which was stolen, that it did not rust and it did not need painting every year. And that was my decision.
Okay. But what about your fire? I see the fire in your back. It's made of stone. Not
the fireplace. Yeah.
The fireplace.
This decision was made in 1931 by engineer Danielson when he built my summer cabin on the Oslo fjord. Must give everybody nice view.
Yes.
And why did he do it? I don't know. I can guess, but I can't talk to him. He's long dead.
Yes. Yeah, but I ask about this because this is I think it's a good question. Where is the border? Because you are a stakeholder. It's a boat for you. You maybe now have some requirements, and Carolina helps you preparing these requirements for new boats. And probably you've seen more than one boat in your life, I believe this. And okay, we can choose aluminum, wood, the fireplace could be made of stones, and so on, so on. And there's a discuss who decide about particular details. Stakeholder, system designer, maybe factory.
Well, let's take a simple example. In Engineer Donaldson made decisions, and he was an engineer, by the way, and they are just there. Now, some decisions, if we don't like them, the owners now, we change them. We redesign